Okay, this lecture is on rates and trends. So relevant empirical questions involving rates and trends refer to various conditions, events, averages, or a status like foster care placement or living with biological parents. And these questions appear in some of the following forms: how many, how often, what proportion, what's the chance that, and so forth. An important way to think about rates and trends has to do with incidence and prevalence. These terms come from epidemiology, but they're widely used in social work and the fields of social care. So let's understand them. Incidence refers to the number of new occurrences, new cases, or new events that happen within a given interval of time, and this is expressed as a proportion of the population at risk of these events. So incidence indicates the risk of acquiring this condition or having this experience. Prevalence, on the other hand, is an expression of the proportion of current occurrences, cases or events, in a population. So it indicates how widespread the condition is at a point in time. And for both incidence and prevalence, again, conditions could be disorders, for example, anxiety disorders, or events, the occurrence of a panic attack, for example, or a status, placement in foster care, as an example. Let's look a little more closely at incidence. So again, it's the new occurrences within a given interval of time expressed as a proportion of the population at risk of those events. So it's a fraction in which the denominator is the number of new cases that occurred in this given interval of time, and the denominator is the relevant size of the population at risk of this event at the beginning of the time interval. So for example, if we're interested in the incidence of foster care placements in the U.S. in 2017, we get that by looking at the number of new foster care placements that occurred in 2017 divided by the size of the child population in the U.S. at the beginning of 2017. So this does not include children who were placed in foster care prior to 2017. Looking again at prevalence, again, this is the proportion of current cases in a population. So the numerator is the number of the cases with a condition, and the denominator is the relevant population size. But there's several types of prevalence. So we talk about point prevalence as the prevalence at a particular point in time. So the prevalence of foster care placements in the U.S. at the beginning of 2018 is the number of children in foster care on January 1st, 2018, divided by the size of the child population on that date. Annual prevalence now is prevalence over a period of time, so the annual prevalence for foster care in 2017 would be the number of children in foster care at any time during that year, divided by the size of the child population in that year. We often talk about lifetime prevalence, and this is the proportion of people who've experienced any episode, for example, of foster care or another condition, at any point in their lives. This graphic might help you understand how we're calculating incidence and prevalence. Now this graphic comes from the CDC's website, and it's hypothetical, of course, but think about having a population of 10 people, and you're interested in the incidence and prevalence of a particular illness. So we have data here, this is called event history data, on the date of onset of illness, how long the illness lasted, and the date of either death or recovery from the illness for each person. And from this event history data, we can calculate incidence and prevalence at various points in time. So let's try this. What was the incidence of illness from October 1st, 2004 to April 1st, 2005? So between the first two vertical dotted lines, I'm going to count the number of new cases. I see at first 4 cases that began before our interval, so they don't count. And then I see 2 cases that started in this time interval, and a third one at the bottom. So 3 new cases. Now, what's the population at risk? Well, we can't count people who've already died, so we actually have, in this time interval, 8 people at risk of new onset of illness. So the incidence is 3 divided by 8. What's the prevalence of illness on April 1st, 2005? Well, at that point in time, now I'm looking at the middle dotted vertical line. How many people have illness at that time? 1, 2, 3, 4, 5, 6, 7. And again, we can't count in the population people who've already died, and you see that 2 people have died by that date. So the population is 8 people still alive. So the prevalence of the disease at April 1st, 2005 is 7 out of 8. Why does it matter? Well, incidence and prevalence can be very different. So this is actually real data on active HIV/AIDS infections over time. That's the red line. And the number, and that's an expression of prevalence if it was adjusted for the population size. The blue line is the number of new infections. It would be incidence if it was adjusted for population size. And you can see that while new infections decreased and then remained stable after the early 1990s, the prevalence remains high and continues to grow because people are living longer with active HIV/AIDS. So again, incidence and prevalence can be quite different. Here's another example. Foster care caseloads have declined significantly from 1999. So the top black line is the foster care caseload. This would be a prevalence estimate if it was adjusted or divided by the relevant population size, but right now this is just a count of the foster care caseload in the US. Or actually, this is in California only. And then it's affected by what we call exits and entries into foster care. So because over this period of time, exits, the number of children leaving care, is slightly greater than entries, the number of new kids entering foster care, then the foster care caseload as a whole declines. So here, entries, the number of new foster care cases, would be a measure of incidence if it was adjusted for the size of the population at risk. But here we have just a count of entries, a count of new cases in California. It also matters because we use these kinds of data in looking at many, many social issues. So here are real data from the Census Bureau on poverty. The first graph is the number of people in poverty in the millions over time from 1959 to 2013. And then the poverty rate is a measure of prevalence, showing the number of people in poverty adjusted for population size. So you see the poverty rate, again, a measure of prevalence, beginning in around 22% in 1959 and coming down to a little bit below 15% in 2013. Another example, number and rate of child maltreatment cases or victims from 1990 to 2013. Again, the top lines are raw numbers of cases, and the number scale is shown over on the left. The green lines are expressed in terms of prevalence because they are adjusted for population size, and that rate is shown on the right side of the graph, the rate per 1,000 population age 0 to 17. So the dark green line is the number of child maltreatment cases at different points in time adjusted for population size, and that dark green line includes duplicate counts, so kids who may have been victims in multiple cases, and the light green line is an unduplicated count of unique children, unique number of children who were victims of child maltreatment per every 1,000 children in the population. Let's take another example, take a closer look at this one. This is a study of youth exposure to violence prevention programs in a national sample in the US. So here, the authors take a look at children who had ever been exposed to any kind of violence prevention program, and those who've been exposed to the violence prevention program in the past year. Now, these data are collected in a cross-sectional national telephone survey. So they basically called several thousand young people and their parents in the US using a method called random digit dialing to get a random sample of the US. And they talked to one child per household. They recorded the age of the child, whether the child had ever been exposed to various kinds of violence prevention programs, and whether the child had been exposed to those programs in the past year. So here we have a measure of prevalence, exposure, lifetime prevalence, and also incidence, exposure, new exposures in the last year. The table shows you the raw data, so that 65% of the children had been exposed to one or more of these programs at some point in their lives, and 55% had been exposed in the last year. So these data come from a variety of kinds of studies. Cross-sectional studies in which all data are collected at one point in time. Longitudinal studies in which data are collected at multiple points in time. And we call these different data collection time points waves. So we say there are multiple waves of data collection. There are essentially three types of longitudinal studies. Panel studies include the same people observed at multiple points in time. Cohort studies include people who share a specific experience and are observed or interviewed multiple times, but not necessarily the same people participate in each wave or each data collection point. So, for example, a birth cohort is defined as people who are all born in the same year. So you could take people born in 1990 and interview them when they're 5 in 1995, and you could take a different sample of people born in 1990 and interview them at 2000 when they're 10. It's still the same birth cohort. These people are all born in the same year, but not necessarily the same people involved in each wave. Now, this is done because panel studies are expensive. It's expensive to follow the same people over a long period of time. And birth cohorts are sometimes used to approximate what we would get with a panel study, but it's much easier to do. We can use birth cohorts. We can use other kinds of cohorts. We could use cohorts of people who graduated from high school in a particular year, or people who went to kindergarten in a particular year. As long as the people shared a specific experience at the same point in time, that's a cohort. The third type of longitudinal study design is called a trend study. And here we're interested in people with a certain characteristic, and these people are studied at different points in time, but it's not the same people who are studied. So for example, in a trend study, I might be interested in the opinions of 20-year-olds in 1990, and the opinions of 20-year-olds in 2000, and the opinions of 20-year-olds in 2010. So I'm interested in 20-year-olds at each point in time, but what's changing is time. So I'm interested in how really birth cohorts differ over time. Another important distinction in these kinds of studies is whether the data are collected retrospectively or prospectively. So retrospective data involve reporting on past events or experiences, and this can be affected by all sorts of bias and error in recall. So for example, if you ask people, how much time did you spend reading yesterday? Our recall is really very inexact, and the further back you ask people to remember, the more inaccurate recall is. So prospective data are generally more accurate, more valid, when we ask people to report on what they're doing now and follow them forward in the future, we can get much better information. So if you're interested in how much time people spend reading, you might ask someone to record how much time they spend every day in a sort of diary fashion, and we'll collect that data going forward. Here's another example, a cross-sectional retrospective study with indirect comparisons. So in this study was conducted in Buenos Aires in Argentina. It involved a hospital sample, inpatient sample of men diagnosed with schizophrenia. And in this study, a psychiatrist in the hospital interviewed these men, a sample of, let's see, 51 male patients, and gathered data from them on adverse childhood experiences. They used a standard ACEs instrument, which is developed in English. They translated it into Spanish and then translated it back into English to make sure the translation was accurate. And they observed that 94% of the participants had experienced at least one adverse childhood experience. So the pie chart, figure 1, shows the proportion of men in the sample who experienced no ACEs, that's 6%, 1 to 3 adverse experiences, 31%, 4 to 6 adverse experiences is 47%, and 7 or more adverse experiences is 16%. So this data are intriguing. 94% of a sample with 1 or more ACEs seems pretty high. And they compare it with ACEs data found in the general population. You see in the discussion section, they are citing references number 2 and number 24 from the reference list. And they suggest that this rate of ACEs is higher than in the general population, in subjects with mental disorders in prison, and in inpatients with a severe mental illness, and among schizophrenic spectrum patients. It's very intriguing. My concern here is that in making these comparisons to other studies, there are potential problems in comparability. So we don't know whether the psychiatrist in this studies administered the ACEs interview in the same way that it was administered in other studies. We do know they created their own Spanish language version of it. So that raises questions about whether the assessment in this study is truly comparable to the assessment in other studies. A better study design would involve direct comparisons between this sample and another sample. It could be a general population, it could be a prison sample, or patients with severe mental illness not in hospital, or schizophrenic spectrum patients not in hospital, but another sample in which the assessment was conducted exactly the same way it was in this sample. That would provide a much better comparison. Okay, more on rates and trends. Here's some very impressive data from Hans Rosling, a very famous public health specialist in Sweden. He's done a number of studies on the relationship between wealth and health of nations. So this graph shows life expectancy on the vertical axis. So the top shows long life, the bottom shows short lives, and on the horizontal axis, we have income per person from poor on the left to more wealthy on the right. Each circle or bubble represents a country. The countries are color-coded so that purple bubbles are sub-Saharan African countries, green bubbles are Northern African countries, yellow bubbles are the Americas, orange bubbles are Greenland and Europe and the former Soviet Republic, Red bubbles are China and Australia and the South Pacific. And the blue bubble is India, Bangladesh, and countries nearby. So let's listen to Hans Rosling talk about trends in the health and wealth of nations in 200 countries over 200 years in only 4 minutes. Here's another piece of Hans Rosling's work showing the relationship between children per woman, fertility, and income per person. And here you see that in poorer countries, fertility is much higher than in wealthy countries. Well, please listen to this lecture by Alberto Cairo on visual trumpery, because it makes you wonder whether you can believe your eyes and what you should believe when you look at graphics. So here, trumpery is defined as the ability to deceive. It's very interesting. The term was not named for a certain American president. And Cairo is interested in graphicacy, which is our skill in understanding graphics. He suggests that this is one of 4 very important skills, along with literacy, articulacy, and numeracy. He suggests that many people don't read graphics or numbers well, but the presence of graphs and numbers in articles or newspapers persuades people that the information is reliable because we think that graphs and numbers are scientific, but they can be very misleading. I think Cairo's lecture is a compelling argument for this point. Here's some other examples. This is a graphic that Alex Funt and I put together looking at the production of systematic reviews and meta-analyses in the social sciences over time, beginning at 1990. And you see the red line is the number of meta-analyses, the green line represents systematic reviews, and the purple line represents reports that include both systematic reviews and meta-analyses. So looking at meta-analyses, meta-analysis is the statistical combination of quantitative data from multiple studies. And this was around well before the start of this project. In fact, it became fairly common activity in psychology and education and later in healthcare in the 1970s. But systematic reviews really only began around 2000 and have really taken off since then. We also see an increase in the number of reports. These are peer-reviewed articles in scholarly journals that use both systematic reviews and meta-analysis. So looking at this graph, it would look like the production of systematic reviews and meta-analyses is increasing. Is that the right conclusion? Well, it depends on the scale of the graph. So let's add another data series. And this blue line shows the number of published research reviews that are not tagged as either systematic reviews or meta-analyses in the same database over the same point in time. And what you see here is rapid increases in the production of non-systematic reviews in the same period. So it would be a mistake to conclude that reviews are becoming more systematic in this time. What messages do these graphics convey to you? Well, the data in them are accurate, I believe, from reading the articles. I think there is something problematic about the presentation. So the graph on the left is really charting results for different age groups. And so these kids are all interviewed at the same point in time. And what you're seeing is, for 5-year-olds, the percentage of 5-year-olds who were exposed to any prevention program or to other kinds of prevention programs. And for 6-year-olds, a different sample, you're seeing the results from that sample and so on up to age 17. But each column, if you will, each age group is really a separate sample. When I look at this, I think about it makes me think of change over time, and that is not what's happening here. This is all data collected at one point in time, and what you're seeing really are results for let's see, 12 different subsamples. And then on the right, pie charts are really difficult for many people to read. And fortunately, the authors have shown actual percentages here, so you know what the numbers are for each of these slices of pie. But pie charts are hard to see. It's much better to show results like this in a bar chart where the bars are stacked next to each other and you can really compare size of the bars. So I think that this is a less than ideal presentation of data in both these graphics. Here's some questions to ask in critically appraising observational studies like cross-sectional and longitudinal studies. Ask yourself, what do the data points mean? What's being counted here? Are you confident in the accuracy of the data from reading the text of the report? Is the scale of the graph meaningful? Do you think there is anything left out? Are all relevant comparisons included? Are the comparisons fair? Are they based on comparable data? And is uncertainty relevant? If so, is it adequately addressed? Albert Cairo talks a lot about uncertainty and how that can be demonstrated in graphics. That's all for now.